Calculations, Lesson 7.4. Similar to 7.3, but one step more difficult. So first we'll start with one that is very much like what we just reviewed. And you'll see one small difference. 3 over x minus 1/4 equals 1/12. So we're going to follow, the good news is, the same exact steps as the last lesson. We find the LCD. We multiply all the parts by that LCD to simplify. That should help get rid of our fractions. And then we simplify the equation. Now the difference here in this lesson is that we're going to start to see variables and other things in our denominators, not just plain numbers. So the only thing that does is it makes finding the LCD one step more complicated because we have to make sure to include those variables, or if it's in a binomial, we have to include the whole binomial. So here, if we just look at the numbers for 12 and 4, 12 can be our least common denominator for the numbers, and with that x, I need to include the x as part of the LCD. So again, if it's there as a variable or as a binomial, we need to include it. Now, the next step is exactly the same. I multiply all the parts of the equation by that LCD. And we just have to be careful that we don't lose track of what we're doing. Again, I like to use some color. You can do that the same if you want. If not, if you're doing it in pencil, just try to keep your numbers clear. Okay, now remember this is a numerator and this is a denominator. I can simplify from a numerator and a denominator if there's something in common. So what can I simplify from this first piece? Jaden? Good, I can get rid of 1x from the denominator and 1 from the numerator, and then they're gone. Now, let's go ahead and multiply what's left. 12 times 3, 36. Now, if there's binomials that you're going to need to distribute, you might want to save that step for the next line, but 12 times 3, that's pretty quick. All right, 12x and 4. What can I simplify from this? Okay,
4.
The 4 and the 12, right? So the x we can't do anything with on this piece because there's no x in the denominator. Divide by 4 leaves 1. Divide by 4 leaves 3. Now don't forget this x is still here from my LCD. So I have minus 3 times x times 1, 3x. Okay, so just be careful that you're going to have some x's or some variables, some binomials. Finally, equal sign, and then 12 and 12. We can divide by 12, divide by 12. That just makes 1. And don't forget this x is still here. 1 times x times 1. All that makes 1x. Now we need to get all our variables together on one side. There we have them on opposite sides. I'm going to take the negative or minus 3x and do the opposite. Move the whole thing over by adding 3x. 1x plus 3x makes 4x. And final step would be divide by 4. And we get x equals 9. Okay. Now I'm only going to show you one more, and I'm going to show you one that is a little more complicated. And then I'll show you just a couple where we'll just practice finding the LCD. We won't do the whole problem, but we'll just practice that. Okay, any questions on this one? Okie dokie. Next problem. 2 over b squared minus b minus 2 over b minus 1 equals 1. Now this goes back to a little bit of what we did in chapter 6. Because I've got binomials, in order to find the LCD, I need to factor the denominators first, when possible. So for example, on this second fraction, b minus 1, I can't factor that. And if I want to picture it as a binomial, we could put parentheses around it, because it is a binomial. But I can't factor anything out of those two. But this first one, I can. what can I factor out of b squared minus b? Brian? A b, which will leave b minus 1. Now, I'm not going to use this original denominator anymore. If I have to factor, I don't want to see the unfactored one. I'm going to stick with this. Now, LCD. I need my little b, my plain old b that was outside. I got to have it. b minus 1, oh, that's in both of these. So guess what? I need a b minus 1. The 1, well, that's like over 1 over 1. We can put any whole number over 1, and we don't need to factor that denominator of 1 into this. It doesn't make a difference. So all I need is b times b minus 1. Now, here's the only thing we got to be careful of is as we multiply all three pieces by this LCD, it's going to get a little messy because there's a lot more to write. So again, I'm using color. You guys need in your own work to figure out what you're going to do to make sure you can read your work. Sometimes that's the hardest part when we get to one like this. This whole thing, now I'm going to put this one, I'm going to put it after. You can put it before. So maybe when you write the problem out, maybe you want to space it out more and leave some blank space around the fraction parts so that you have room to write this. And again, using color might help. It's up to you. Figure out what works for you. Now if we come back and simplify, remember we're looking at the numerator and the denominator. And here we're not just thinking of numbers, but we're looking at what's the same. If it's the same in the numerator and the denominator and it's being multiplied, I can cancel it. So in this first one, I can cancel the b and the b, and b minus 1, b minus 1. I can cancel all of it. You can cancel whole binomials. All that's left, 2. Now it's not all going to work out maybe that neatly. If we look at the next piece, if I have a denominator of b minus 1 and I'm multiplying by b times b minus 1, what can I cancel, top and bottom? Daniel Q?
B minus 1.
Okay, good. The whole binomial, b minus 1 and b minus 1. Now don't forget that little pink b that I have there, that's still there. 2 times b, or b times 2, either way we put the number first, to minus 2 times b, equals. This, after the equal sign, can I cancel this one and this minus this one here? No, why not? Tammy?
Because like that one, like it's in like parentheses, and it's not.
Yeah, this one here is in the parentheses, it's part of the binomial, or you could say because of the addition subtraction, in this case subtraction, we can't cancel. Good. Now, 1 times b minus 1, well 1 times all of this is just itself, so it's going to end up being just itself, b times b minus 1. If that was any numerator or number other than 1, we'd have to distribute, or we'd have to multiply it. And what you can do here, guys, is, let's say this was a 2, you can say 2 times b and write 2b and then distribute in the next step. I still have to distribute this b. So my 2 minus 2b, those can't combine, they're not like terms, so I'll leave them for now. Here if I distribute b times b squared, b times negative 1, negative 1b. You can write the 1 if you want. Now, this is the hardest you will see, and hopefully not too hard. We got to get the like terms together on one side. Now the b squared and the plain b's aren't alike, so I'm going to leave the b squared alone. From these, I'm going to take my minus 2b and I'm going to do the opposite. I'm going to add it plus 2b on both sides. And while I'm doing this, I'm going to go ahead and take this 2. I'll show you why. This problem is a little different than the others because we have a b squared. If I do minus 2 and minus 2, I got to do it on both sides. What am I left with over here on the left side? If I've canceled everything out, Vincent? 0. B squared. Minus 1 and plus 2b's. Negative 1 and positive 2 makes positive 1b. And I brought my 2 over. Here's the difference on this one, and most of them won't have this. You might only get one like this, so I'm showing you here. The rest of them they'll solve, by the way, more like this one solved, okay? For this one, because we have a b squared, that's different than b. We did this, at the end of chapter 5. Here's a trinomial that's set equal to 0. First thing I'm going to do is I'm going to reverse FOIL and I'm going to try to factor it. The only way to get b squared is b times b. The only way to get 2 is 1 times 2. And if I have a minus 1 and a plus 2, 2b minus 1b positive 2, these are the factors. Does anybody remember what we did when we had things factored like this equals 0? Two things that are multiplied that equal 0. Oh no, nobody. Okay, here's what we did. This was just chapter 5. Not that long ago. One of these must equal 0, right? If we have two things that are multiplied that equal 0, now you don't need to write this down, but what we did when we did this was we looked at something like this. We said a times b equals 0. What does that mean? Well, if we're multiplying two things and the answer is 0, it means either a equals 0 or b equals 0. So if I look at this, this means that one of these binomials must equal 0, but I don't know which one. So I go, well, maybe b minus 1 equals 0. Maybe b plus 2 equals 0. One of them equals 0 because when I multiply them, I get an answer of 0. And I got the 0 because I moved everything over. If you see a variable squared, you have to do it this way. Solve, okay, plus 1. b equals 1. Or minus 2, b equals negative 2. You have two possible answers. Now you only are going to get something like this if you get a variable squared. If you get a variable squared in your work, you want to get everything on one side so that it equals 0. This whole thing could be flip-flopped. But you want to have that squared variable be positive. So that's why I moved all this stuff over here. I could see b squared. I don't want to move that to the left and then have negative b squared, because that's hard to factor. So you get your trinomial all on one side, equals to 0. You do reverse FOIL to get your two factors. Set each factor equal to 0. One of them must be 0. We don't know which one, so we set each one equal to 0, and we get two answers. Izzy, are you all right?
Yeah.
Sit up and take notes. Or if you're ill, I can send you to the office. Are you sick? Then sit up and take notes.
I feel the notes.
Sit up. If I'm asking too much, go to the office. I'm asking you not to lay down in class. And if you'd like, I can send an email to your